Hello and welcome, students. My name is Shampa. Today we are going to study some properties of rational numbers. The properties of some of the important properties of rational numbers are closure property, commutative property, associative property, additive and multiplicative identity, additive and multiplicative inverse, and distributive law of multiplication over addition. These are the basic properties of rational numbers, but in today's session, we will discuss the closure property and the commutative property. So let's begin. Now let us understand closure property. We know we have four operators: plus, minus, multiplication, and division. Now, if we perform operation between two rational numbers using any of these operators, in that case, if the result is a rational number, we would say that rational numbers are closed under the operation. Let me explain it to you with an example. Say we have 2 by 5 plus 3 by 5. We are going to get 5 by 5, which is a rational number. 7 by 8 plus 9 by 8, it's going to be 16 by 8. We can convert it to the standard form, and again we will get 2 by 1, which is a rational number. So we can say that rational numbers are closed under addition. Let's see if this is the case with subtraction. We have 7 by 5 minus 3 by 5. Let's subtract two operators. We will get 4 by 5, which is a rational number. We have 9 by 16 minus 17 by 16. We are going to get minus 8 by 16, which is minus 1 by 2. This is again a rational number. So, rational numbers are closed under subtraction as well. Now let us multiply two rational numbers. So when we multiply two rational numbers, we will get these two rational numbers, we will get 14 by 15, which is again a rational number. Now, does it hold true in case of division? Let's see. 5 by 7 divided by 7. So it's going to be 5 by 7 into 1 by 7. It's going to be 5 by 49, which is a rational number. So we can say that rational numbers are closed under division, but that is not the case, because if you divide a rational number by 0, the result is not going to be a rational number. If you consider this as P and this as Q, the very definition of rational number says that P and Q should be integers and Q should not be equal to 0. So we concluded that when we perform addition, subtraction and multiplication between rational numbers, the result is always a rational number. But rational numbers are not closed under division. That is, when we divide two rational numbers, the result may not be a rational number because of the existence of this case. You cannot divide a rational number by 0. So if there is an exception, then we would say we cannot make it a law if there is an exception. So because this exception is there, then we would say rational numbers are not closed under division because the result is not going to be. So that ends our discussion of the closure property. Let's move on to the commutative property. Now let us understand the commutative property or commutativity. It says that if we add, subtract, multiply, or divide any two rational numbers in any order, and if the answer is the same, then we say that that particular operation obeys the commutativity. Let us understand. We have 7 by 8 plus 3 by 4. We have got 13 by 8. So 7 by 8 plus 3 by 4 is going to be 13 by 8. And 3 by 4 plus 7 by 8 is again going to be 13 by 8. So we can write it like this. 7 by 8 plus 3 by 4 is equal to 3 by 4 plus 7 by 8. So addition obeys commutativity in case of rational numbers. Is this the case with subtraction? Let's quickly verify with the same examples. We will take the example that we took above. Okay. We have 7 by 8 minus 3 by 4. We have 7 by 8 minus 6 by 8. And the answer is going to be 1 by 8. Right? Now let's see what would happen if we subtract 7 by 8 from 3 by 4. Is it going to yield the same result? 6 by 8 minus 7 by 8. It's going to be minus 1 by 8. So in case of subtraction, the laws of commutativity are not obeyed by rational numbers. Let's see what would happen in case of multiplication. Say we have 4 by 7 into 14 by 2. Here we can cancel them and we have got 4. Now let's change the order we did the multiplication. Let's change the order. We have 14 by 2 into 4 by 7. Result is again going to be the same. So we concluded that in case of addition and in case of multiplication, the laws of commutativity are obeyed. However, subtraction does not obey commutativity. What does that mean? When we subtract, when we change the order of the rational numbers in case of subtraction, the same result is not obtained. So, subtraction does not obey commutativity. Let's see if division obeys commutativity. Now we will perform division between 4 by 7 and 5 by 7. Let's see what's going to be the result. 4 by 7 into 7 by 5, and we have got 4 by 5. Let's see if we are going to get the same result if we change the order of our division. Let's do it quickly. We have 5 by 7 as the numerator now, and 4 by 5 is the denominator. So this is going to be 5 by 7 into 5 by 4. So what have we obtained? It is 25 by 28. 25 by 28 and 4 by 5 are definitely not equal. So, in case of subtraction and division, the laws of commutativity are not obeyed. Only addition and multiplication obeys the laws of commutativity. So, that's it for the day and for this session. In the next session, we will discuss few more properties of rational numbers. Till then, please take care of yourself and have a good day.